We will complete lesson 4. It is about using function notation to describe rules. There's actually 2 lessons on that. So lesson 4 and 5 will be basically on the same stuff. But today specifically, we will be looking at some rules that describe functions and write them too. You'll know that you're successful if you can make sense of rules of functions when they are written in function notation, create tables and graphs to represent functions. And if you can also write the equations that represent those functions. Just a side note, I record all the time and link it in here all the time, but I kind of want to send a message to like my 5th and 6th hour through this video because I'm not going to be here for 5th and 6th hour. So they'll be watching this. You guys get like the real experience. But like the normal protocol whenever I'm absent is usually to watch a video, take notes, whether it's on your own paper because maybe you're at home absent as well, I don't know, or with the provided note sheet. So normally I give it to the sub, but since it's only like 2 classes that have to like remember to grab it on their own. Remember, note sheets are always over here. Grab one and then the video will be in here and you can take notes that way. But again, you really don't need the note sheet. You can always take notes on your own paper. And anytime I'm absent, I usually have you guys turn it in. So 5th and 6th hour will be responsible. You guys won't. You guys will just say that for your private check. But 5th and 6th hour, we'll have to turn it in. I'll put a link in Schoology that's just going to be for 5th and 6th hour to make sure that they did something while I wasn't here, or that they at least made it up on their own if they choose to goof off. But yeah, the puzzle piece will be lesson 4. So after this lesson, you should have 1 through 4 done if they're not already. So that's also something to work on. And we're really trying to keep them short and manageable, only covering like the essential information. So if you're struggling with any of that, you need to ask. And hopefully you guys, my first hour had time. So I think you guys will have time today to ask. And for 5th and 6th hour, I'm also available via email. No one ever tells me that they're struggling. So if you are struggling and you're just not saying anything, like how am I supposed to know how to help you? Like you need to vocalize, say this problem is hard, and then I'll give you strategies for how to solve problems like that. But otherwise, if you don't ask, then you are 100% good. And if that's not true, then you need to ask. Quiz won't be until next week over lessons 1 through 5. So plan that for Wednesday. You do have a math benchmark that Tuesday. So just, take it seriously for many reasons. One, I do put it in the grade book. I only grade you on the ones that I know I taught in here, but still try on everything because it would be like extra credit if you got that right. And just in general, like you heard in the announcements, the ACT Aspire test that you'll take in April, like this benchmark helps you with that. And they will be making tutoring groups based on how well you've been doing on the benchmarks. So if you're just like guessing and getting a low score, they're going to make you come to tutoring when you might not have to. I do want people that score low to go to tutoring, and they will like make you. So I want like real data. I want to see what you actually know from this benchmark. So that will be Tuesday. Just on everything we've learned so far. So questions on that? All right, I'm hoping to get the unit 2 test like finished grading. All the constructed responses are graded. I need to enter them. And so far as like the other parts, the packet, I've only gone through 1 class. But that 1 class compared to like their first attempt and their second attempt, for some people they improved like a little bit, but it was still an improvement. For some people, they improved like multiple letter grades. All right, a lot more A's this time around on the retake. So, just keep that in mind. And then if you're still scoring low, you can come to tutoring and we can try to get you back up to where you need to be. But that should be going in. So questions on anything? All right, so now to the first part of the lesson, which is this printed on your paper? I don't think so, huh? Okay, so still, you could take notes on your paper from the warm up, and that would count towards your binder check, like completion of notes. But the visual is only on the screen. I'm just gonna give you 2 minutes to pick out something that you notice and something that you wonder. All right, so just look at the screen at the 2 tables. Think of something you notice and something you wonder. Volunteers, what's something that you notice? All right, no one? All right, Peyton Ramirez, what's something you notice? Can you really be wrong about things that you notice? So these should be the easy questions, Brian. Okay, different formulas. For each table, anything else that we notice? Hayden, something you notice, anything? There's negative numbers in the tables. Brian? Okay, so one is f of x, the other is g of x. All right, other volunteers. Jordan. There's nothing you notice. William. Allison. Okay, so x to the power 3. There's decimals. All right, I think this is a pretty good list that we have going so far. What about things that we wonder? Okay, what are we wondering about? Why is there a G? All right, Anthony. Okay, what are the equations for? All right, anything else, things that we're wondering? Brian, anything you want? Okay. All right. So good notice and wonders. I don't see any notice that is incorrect. I mean, usually things that you notice aren't incorrect. But let me pull up something that my first hour said, because I don't know if they just don't like watch the videos when I'm gone, or they just really didn't understand. Maybe I was confusing. But we had to kind of correct some common misconceptions in our notice and wonder. And I just want to make sure no one in here has those misconceptions too. So like, I welcome wrong answers, because usually someone else in the room is thinking the same thing. And then we need to correct those misconceptions. So first thing said that they noticed that these are not linear functions. And that was incorrect. Which one is a linear function, f of x or g of x? F of x. Not just because it already says linear on it, but linear is in what formula? Y equals mx plus b. So if you have a number times a variable, that's usually your rate of change. So like how we have a negative 2x right there, that could be like my slope. And then a single number would be like your y-intercept. So that is a linear function. It may not look that way because they didn't put these in order, and they didn't also like take a consistent pattern, but it is linear because it's y equals mx plus b. And remember, f of x is y. F of x replaces y. So like in function notation, f of x is your output, so is y. All right. They also said no matching numbers between the functions. I think what they really meant to say was no x's repeating, which is true. None of the x's repeat in each chart. So are these both functions? Yes or no? Yes, because that's the rule. If they don't repeat, then they're both functions for the x. Okay, what else? Yeah, and then their wonders, I mean, your wonders cannot be incorrect, but they were wondering things that we could figure out from looking at it. So let's just look at that too. They said they were wondering what is x. And I'm like, what do you mean, what is x? X is -2, x is 0, x is 1, x is 3. I think they just didn't know, they didn't know what they were looking at. All right, this is just a normal input output table. And they happened to put x there. Maybe they really meant what does x represent, but when I asked them, they just didn't know what x was. All right, x is in the chart. These are y's, or these are outputs. And then how did they make the equation? That's also something you could wonder, like, I don't know what they're representing in the real world, but I'm sure that they could represent something in the real world. So any questions on the warm up? All right. They also said that there was no pattern, which as you can see, we crossed it off because there is a pattern. All right, maybe not one that you could visually see without this being there, but this is the pattern. For each input, for each x, they are timing it by -2 and then subtracting it from the 10. All right, so that's what this is the pattern. And this shows you in function notation, you replace the x, like if it gives you a number for it, anywhere that there's an x. The left is just function notation. So that is not f times 1, it's f of 1. And then on the right, we actually simplify that part. That's how they're getting 8. By order of operations, multiplying by -2, and then 10 minus 2 is 8. So any questions on that at all? Okay, so just kind of making sure if someone had those same misconceptions that we address them. All right, now let's go on to the first activity, which is printed on your paper. We have a function takes any input and cubes it to generate the output. So also in the warm-up, we do have something being cubed, so that's what we call anything to the power of 3 is cubing it. What does it mean to have something to the power of 3? You're multiplying that base number, so like if I take the -2 by itself, how many times? 3 times. So for the first one, it's -2 times -2 times -2. And I mean, you can put that in your calculator, whatever you want, but 2 times 2 times 2 is 8. You have an odd number of negatives, so your answer is negative. All right, and then you do the same thing again. So apply that to this problem. Find the output when the inputs are 0, 1, 3, and x. So if you need to divide and conquer, go ahead, but I'm gonna give you about less than 2 minutes. So find the outputs when those are the inputs. And then write the relationship using function notation and name the function g. All right, so what is the output when the input is 0? 0, good, because basically if you're picturing it as in this machine, input is 0, cube the input, 0 times 0 times 0 is 0. So good. Then we're gonna write that using function notation. And they want us to name the function g. So what does that mean? If I need to write this using function notation and name the function g, what does that mean? Well, it is 0, but I just have to show it in using function notation. You guys remember that? So what does function notation look like? All right, good. So instead of f of x, they want you to name it g, so g of x. X is usually your what? Input. So if I want to show that answer, my input is 0. And then, so basically g of x equals y. So y is my output, right? So what's my output when my input is 0? Right, good. That's what it's asking for. So not only for you to be able to apply that rule, but to put it in function notation. All right, what about when the input is 1? What's my output? Good. So 1 times 1 times 1. And then when my input is 3. Good. That one is 3 times 3 times 3. Again, feel free to use a calculator, but multiplying it by itself 3 times. And then how do I write the last one? What's my input for when it's that? So I'm going to write it as g of x. And then I need to cube the x. So what is it going to look like? X cubed. All right, because x cubed is x times x times x. I don't know what x is, so I can't give it like an actual number. So just multiply it by itself. When we're putting our final answer, it's usually simplified. You don't want to write x times x times x. So multiplying it by itself 3 times is cubing, so that is the most simplified. All right, so your last one would look just like that. So for any number that x is, you can get an output just by cubing it. So questions on this problem? All right, then moving on. Oops, let me show you the answers. Here are descriptions and equations that represent 4 functions. So they're not in any particular order. Your first step within your groups is going to match each equation with the verbal description that represents the same function. So I'll just read them to you. You can look at what the equations are. They're printed on your paper too. So A says, to get the output, subtract 7 from the input, then divide the result by 3. B says, to get the output, subtract 7 from the input, then multiply the result by 3. C, to get the output, multiply the input by 3, then subtract 7 from the result. D, to get the output, divide the input by 3, and then subtract 7 from the result. So first thing, being able to translate numbers and symbols to sentences that describe what's going on. So determine that first before we move on. I'll give you less than 2 minutes. All right, so moving on. Which description best matches the f of x function? A, B, C, or D? Who thinks A? Who thinks B? Who thinks C? And who thinks D? All right, so the 3 people that voted, I mean, not surprised. But I don't know, it's all about how you make it. Like if you're not even trying, you can't even attempt it when there's no like assessment points dangling over you. Like, I don't know how to motivate you to do that. It's all like an inner want for you. Like, either way, even if you're wrong, like who cares? Just put your answer out there. So when you don't vote, it tells me that you're not even trying. So those of you that chose C, let's see if you're right. So to get the output, multiply the input by 3, then subtract 7 from the result. So according to order of operations, do we multiply first in this one or subtract? Should I just like move on? Should I just assign you the puzzle piece and just sit down? Because I'm not doing this like for me. Like I can't even get like a simple yes or no response from you. So that's what that's telling me, that I should just move on and do things that I need to get done. You guys can just try from either doing well in the puzzle piece or failing because you never even did the lesson. So which one is it? Should I waste my time or are you going to participate? All right. So again, the question that I've asked a ton of times now, according to order of operations, do I multiply first in this one or do I subtract? You multiply. What is the order of operations? How can you know the order of operations? Good. All right, parentheses, exponents, multiplication, division from left to right. So that's in the same step. Addition, subtraction from left to right. So in this one, no, subtraction does not come before multiplying. So yes, those of you that did answer, it is C for the first one. All right, what about G of X? Which description best matches G of X? All right, B as in boy. All right, let's see. So to get the output, subtract 7 from the input, then multiply the result by 3. Why would we in this one subtract first and then multiply? Because of the parentheses. Good. So then, again, parentheses, very first, suddenly pushes whatever's inside them as first priority. So yes, this one is B. Which one best matches H of X? All right, I think I heard D. So let's see. To get the output, divide the input by 3, then subtract 7 from the result. So yes, this one has division before the subtraction. So that means the last one must be A, which why would in that one we subtract before dividing by 3? Well, I mean, the fraction bar does mean divide, but why are we doing it second? All right, so when it's set up like this, so in H of X, it was separate, right? Like you divide this in a fraction and then you subtract, you do your normal order of operations. When it's in a fraction though, you always work out your entire numerator, then work out your entire denominator before dividing. So if you kind of want to picture there being parentheses, that's basically what it's telling you to do when it's in fraction form. So like in H of X, there's nothing to work out in the numerator, there's nothing to work out in the denominator, so that's why you would divide and then subtract like normal. But down here, you need to work these out completely before dividing. So questions on this exercise? All right, so that step 1 is making sure that we understand how to translate the descriptions into like numbers and symbols. So now for one of the functions, you're going to figure out which one, that when the input is 6, the output is -3. And you'll figure out if it's F, G, H, or K. Since most of you have 4 in your team, you can split up the work. Each of you try a different function, and whoever gets done early, well, like if you're a group of 3, can do the last one. But for one of them, the input is 6 and the output is -3. Determine which one. Give you 1 minute. So which one is it where when the input is 6, the output is -3? Okay, I have 1 vote for G. Anyone think it's something different so that we could compare those two and you can find the mistake? Don't be shy. We're on this bullet point. So everyone got the same answer then? Okay, I heard H, I heard F. All right, let's see. So then for the inputs, like when it says the input is 6, what does that replace? The X, and we're using these ones from the previous question. So for the G of X, it would look something like this. G of 6 equals 3 parentheses 6 minus 7. Normally, anytime you plug things in, I tell you to use parentheses. Sometimes it makes a difference, sometimes it doesn't. In this one, leave the function notation alone. That's just telling you what the input is and what function we're using. On the right, do your order of operations. What do you do first? So what's 6 minus 7? -1. And then what's 3 times -1? -3. So I think we found our answer. It is the G of X. All right, but let's see why we might have thought it was something different. So I heard F of X. All right, when we plug that in, it looks something like that. And what's 3 times 6? No. 18. And then -7. 11. So that is not an output of -3. The other one that I heard you guys say was H. So let's try that one. So H of 6 is 6 over 3 minus 7. What's 6 divided by 3? And then what's 2 minus 7? -5. All right. So really, all it's telling you to do is just replace the X with that number and simplify. We just leave it like this so that we can clearly see what function we use and what our input was. So the right answer for this bullet point is G of X. Question? All right, now answer the last bullet point. Which function value, F of X, G of X, H of X, or K of X is greatest when the input is 0? And then what about when the input is 10? So again, that's why you're in groups. There's like 3 or 4 of you to a group. You could split up the work. Whoever gets done early could do the last one. But for each of you, solve when the input is 0, when the input is 10. Which of these 4 functions, and again, just to kind of clarify, the actual equations are up here. But which of these has the greatest output when the input is 0? All right, got some disagreements out there. I'm going to put it in the calculator so you could see all of them at once. I'll just go down the list of how they are on the paper. So first, we're evaluating when the input is 0. All right. As long as you know how to use a calculator, you can put the whole thing in at once and not really have to like do order of operations. Just let the calculator do it for you. I mean, you still need to know your order of operations, but this way might be fastest. than doing it by hand. All right, but if you look at all the different answers I have, which answer is the greatest? The negative 2.333 repeating is the greatest, because would you rather owe $7, $21, or about $2? All right, that's how the negatives work. So the greatest is the K of X for when the input is 0. All right, what about when the input is 10? What is all that we're changing? All we're changing is the X. So everywhere that X is, we're now making that a 10. Which one's the greatest? The F of X. All right, that one. The only way to know for sure is to plug it in and then compare the numbers. You could assume, but you all know what assuming does, but the 23 is definitely the greatest out of the 4 answers when the input is 10. So questions on that? All right, we're almost done. We just have this problem, which is a really great test question. So it's rules for area and perimeter. They love to put that on tests because they assume that you know like your basic rules for like squares, triangles, and all that. I'll scroll back up to it. Build up that.
I told you.
All right. So then now we're on this problem. So a square that has a side length of 9 centimeters and an area of 81 centimeters squared. The relationship between the side length and the area of the square is a function. We're going to complete the table with the area for each given side length. So what do we know about squares? Yeah, 4 sides. Yeah, 4 sides. Anything else special about squares? They are 2-dimensional. They do have right angles. All the sides are equal. All right. So that's all things that describe squares. So if I know that one of the side lengths is 9 centimeters, what must the other side length be? 9 centimeters. Right, so that makes sense that when I do the area, because what's the area of any like quadrilateral almost? How do you find area of a square? Or a rectangle? Length times the width. So that's why theirs was 81, because it was 9 times 9, right? You're gonna now figure out the area when the side length is 1, when the side length is 2, when the side length is 4, when the side length is 6. And then this very last one is an F, not an 8. All right, so complete the table. And then see if you can come up with the rule yourself. So we'll definitely do that together. So if my side length is 1, what's my area? 1 centimeter squared. What about when my side length is 2? When my side length is 4? When my side length is 6? And when my side length is S? Good. Length times width. The side of the square are all equal. So if you know one side, you can figure out the area by finding it by itself. So great. Now make the rule for that. And it says it wants the function to be A. And it wants to give the area of the square when the side length is S. Using function notation. So see if you can do that for a second. All right, they can take a shot at the function notation part of this. What's the function name, I guess you could say? What do they want us to call the function? So that would be a parentheses. They don't want us to use X for our input. What do they want us to use for our input? S. That's what S. First side. So A would probably stand for area. So that's what they want you to call the function. S is for side. Equal to what? What are we doing to each side length? In other words, so S squared. That's our rule in function notation. It's what we're doing to each input to get the output. Function notation is just the name of the function, and then in parentheses would be the input. Usually X, but this one they wanted the input to be the side length. Make sense? So then, other great test question. What would A of 2 represent?
Area where.
So 4 is its value. That's its value. That's the second question of this. What does the A of 2 represent? With if it says A of 2, what do we know about that square? Yeah, you know the answer is 4, but what do we also know about the square? What does the 2 represent? Good, that's all we're looking for. Area of a square with a side length of 2. This curriculum loves those like interpreting parts of math statements. So not just doing them and knowing what they mean. It shows an area of a square with a side length of 2 is 4. Then when you sketch things on a graph, how do you do that? Like what's a point that we know is on the graph? Good, what else? 2, 4. What else? Good, where are we getting them from? The table. They're all paired values. Your input is your X, your output is your Y. You can graph all of these. I don't think you can graph the S of or S squared. So there's no S or S squared there. But yeah, you could also tell from function notation. Input, output. So if the table wasn't there, you should be able to graph that too. All right, but then just graph it and pay attention to how your y-axis is labeled because there's how many tens there. 1, 1 would be like right here-ish. 2, 4, kind of right there. Because again, it counts by tens, you know, so towards the middle. 4, 16. About there, and 6, 36. Should I draw a line through these dots, do you think? Why do you think so? Just to connect them. It is a continuous graph, and here's how you know. Can I have a decimal of a side length? Yeah. Like in the real world, they probably don't measure things perfectly. They might have like 2.5 centimeters or something like that. Can you have a decimal of an area? Yes, you can. So because you can have a decimal for both, you can connect these dots. It is continuous. Questions, comments, concerns?